Hello guys, and welcome to another Hackerrank tutorial. We're going to be solving between two sets. Unfortunately, all I've done today is whiteboard this problem. My niece is around, and I was pretty much like babysitting, and she's a handful. But I didn't really have time to even code the solution down. All I did was whiteboard the problem, which brings me to a significant step here. It's always good to just write your solutions on paper. All right. Don't use an IDE when you solve these problems. Every solution that I've come up with has been done on either a piece of paper or on a whiteboard. You can invest for one on Amazon.com. You can use regular paper. It's always good to write some pseudocode before you dive on the text editor. And a lot of people do that, right? And that was me too. I used to do that a lot. However, the thing is that when you go on interviews, sometimes you have no compilers to actually help you. They give you a plain editor and they say go, all right? And depending on how you actually structure your idea and your explanation, that could be either going to help you get a job or it's not going to help you get a job. I don't really believe in strictly in coding questions. I feel like sometimes people have more experience on projects, and that's actually what you would use if you actually get a job. But I guess it says the filtering process, right? Anyway, I never got to coding the question. I did, however, created some pseudocode to solve the problem, and we're just gonna go ahead and implement it. So this video might take longer. However, I do whiteboard every single problem. Okay. Anyway, so this problem we're given pretty much two sets of arrays, right? And it says that the elements of the first array are factors of the integer being considered, and the integers being considered is a factor of all elements of the second array. I'd really like to skip the first example here and go straight to this example that they give us here. So the first thing that we can tell is that the array that we've been given actually is not uniform. All right, so it can have different sizes. Then they're given the inputs for the first array and the second array. And this problem is pretty interesting because if you first read it, you might not really get what it's saying, but when you look at the example, it kind of hits the point. So we're given 2 and 4, right, for the first array, and you can see that after that it gives you a list of numbers that it generates, right? And this is called in between two sets because first what it does is that it takes the LCM of the first array, and then it takes the GCD of the second array, and it uses the LCM of the first array to calculate based on multiples of the number that you get back from the first array to generate this list. So here we get 4 for the LCM of the first array, and for the second array we get 16, which is going to be the GCD. So we create multiples of 4, which is going to be 4, 8, 12, and 16. We end at the GCD of the second array. All right. Apart from that, there is not really much to this question. The thing is now you have to get the LCM and the GCD. If you're new to coding, all right, start making Google search your best friend. There are tons and tons. Literally, I know literally about 3 or 4 GCD functions. All right, I know how to write at least 3 or 4 GCD functions. Some of them just use bitwise operators. Some of them have a boundary. They're really sophisticated ways of doing it. If you don't want to do that, then you can look into the big integer class. Okay, there's a GCD method there. You can use that as well. The thing is, get used to finding ways to come up with the solution without having to work too hard. The thing is to get the concept of what you're trying to write. All right, well, I'm talking too much and I'm yapping. Well, let's go ahead and first thing is to build the GCD and the LCM function. All right, so we're going to do the GCD first because we can use the GCD to calculate the LCM. let's make this static, and let's call this the GCD. It's gonna take in int x, int y. If y is equal to 0, we're going to return x. If not, then we're going to recalculate. So I'm gonna do this recursively because it's easier that way. I'm gonna pass in y, and then it's going to be x mod y for second argument. And then from the GCD, we can use that to calculate the LCM. So we'll do static int LCM. It's going to take in the same parameters, int y, and we're going to return. Let's do x times y divided by the GCD of x and y, and that's easy. The problem is because well, I have like used this before a couple of times, so that's the reason why I can really do it out of my head. If you don't know how to come up with this is not a tutorial to teach you about the GCD and the LCM. Look online for a good documentation about this too. There are really cool ways of doing this. All right, there's some really cool ways. If you actually follow my project order series, there's actually a problem there that you need to find a very efficient way of calculating the GCD. And I remember that problem. I worked really hard on it, and I eventually found a really clever way of doing it, which actually requires a lot of bit shifting. But it was cool to learn that there's multiple ways of doing it. Okay, so now that we have that, what we need to do is we need to go ahead. We need to figure out the LCM of the first array. All right. So what we can do is, since the array is going to be a, we can create an int, call it ax, and we can copy the first value. Since we have to go through the entire array to get the LCM, so we're going to say for int I equal to 0, I is less than a dot length I plus plus. All right, and then we're going to say that ax is going to equal the LCM of ax and ai. All right, and then we need to do the same thing for array b. So we're going to say int bx equal to b0. Right, and you just need to create the for loop. So int I equals to 1. My bet it should be 1 and not 0 because we already have copied 0. All right, I'm gonna do I is less than b dot length, right? I plus plus. Bx is gonna equal the GCD. Is going to be bx and the array, so current array index. All right, so we've pretty much calculated the LCM, and we've calculated the GCD for the second array. All right, so now we need to go ahead and generate these multiples based on the LCM as the lower bound and the GCD for the second array as the upper bound. So I don't really know how many elements are going to be there, so we can use a list since it's going to be dynamic, and let's do integers, right? List is going to equal to new array lists. All right. How do you want to do this? Okay, I guess we could use a bit shifting for this, or since we know the initial value, right, for ax, since we know we have ax, right, which is going to be the lower bound value, we could just copy that. So let's do something like temp, right? It's going to equal to AX, because we want to increment by AX, and just say while temp, right, is less than or equal to BX, since that's going to be the upper bound. We want to go ahead and do a list, right, dot add temp, and we want to increment temp by AX. So we're going to say temp plus equal to, do we actually have to do that? Yes, we do. We do actually have to do that. The reason is because if we just don't make a copy of this and we try to increment by temp, let's say that temp becomes 8, and so you want to add 8 on 8, it's going to skip multiples. So let's add AX to this. All right. Okay. So now that we're here, we've generated the multiples. So we just need to go ahead and check the B array to every single value that we generate in between sets. Okay, so I didn't really explain this part that much. So we have these 4 values, right? So what we have to do is we have to go take this array and check against every single value. So at 16 we check against 4, then we check 32 against 4, and then 96 against 4. So 4 checks out. We go to 8. So 16 divides 8, 32 divides 8, 96 divides 8. So now we're at 12. Well, 16 doesn't divide 12, so we can just go ahead and eliminate 12 right away. Next, we're at 16. So 16 divides 16, 32 divides 16, and 96 divides 16. So we only care about the numbers within the generated set that actually counts, right? That actually is a multiple of every single number in the B array. Okay. Okay, so with that said and done, what we can do is this. We need to keep track of a counter of the number of elements that is going to equal the set here that actually passes the multiple check here, right? However, just one thing that we need to consider is that the numbers that we generate here, right, or it could be bigger than the list here. So we have to go through the generated list first and check against when we check against this. Okay. All right, because it seems that if we have the outer loop as the number here, eventually it might go to a state where there are numbers here that doesn't go through to check, and so we will probably get a wrong answer from that. All right, so let's go ahead and, you know what, I'll utilize the for each loop. So I'm just gonna, let me do F, and let's pass in list. So we're gonna go through every integer in list, and then we can go through every integer in B. So I'm gonna do G here, and I'm gonna pass in B. All right. Okay, so we can say something like if G, right, if G mod F is equal to 0, so that we know that's actually a multiple. However, this might not actually be the best way to do this. We should flip it over. So for 16, we're gonna say that if, right, 16, if 12 isn't a multiple of 16, then there's no point to actually just keep checking for the rest of them. We could just break right there. So we're gonna reverse this and say that if it's not a multiple, right, then we need to go ahead and do something. So we need to break, right? But then it doesn't really this doesn't really solve any issue here, because even if we break, how do we know how to increment? So it's gonna be nice if we actually had, you know, a boolean here or something, just something to check the current state. So I'm gonna call this mul for multiple for short, and I'm gonna set this to false initially. All right, so initially everything is not a multiple, and then here what we're gonna do is that we're going to say that the multiple is gonna equal to true. right? So the reason is because once we exit the inner loop, I want to use the outer loop for incrementing. So here we can just say that if we're going to say if mul, right, meaning that it's true. We could just do a counter plus plus, right? So it makes more sense that way. I don't know if there's like a clever way to do this without using two loops, but the way that this sentence, the way that the problem is structured, it seems like you have to use two loops for this, right? If there are clever ways that you guys found out, you guys want to let me know, leave a comment down, all right? I'm always interested to see other people's solutions. I can learn more from you guys' solutions as well. And then here we just need to go ahead and return the counter. All right, so let me go ahead and browse this again and see if there are any errors that I've made that could need some fixing. So A0, B0, 1, B, AI, BI, lists. All right, I think this this solution should work. I mean, this is pretty much what I whiteboarded, so I think we're okay here. Let me go ahead and we can run this first. And it's wrong. So we need to go ahead and we need to figure why. Okay. So normally you might run your thing and you might get the wrong output, right? It's very normal. The thing here is to figure out why it's wrong. Okay, so debugging. First thing we want to do is we want to go ahead and let's look at our GCD functions, right? So I'm pretty sure that this is right, and for the LCM, so it's supposed to be x times y divided by the GCD of x and y. So that is good. All right, for this part right here, we have A0 start at 1 less than 8 at length. We do AX is the LCM of AX and AI, so this is good. So we'll go for B. So we're going to say that it's going to be start at 1, B less than length, to get the GCD, so that's fine. Okay, so we create a temp there, and here we adding temp, and then we incrementing by AX, which is good. So the problem probably lies here. Okay. Okay, so I made you can see here that this right here should, so if this is false, right, and this passes all the states, well, this is actually false. All right, so it never actually increments when it should here. So actually what this should be is true, right? So it should be true here, and here we should turn it off to false. So we're gonna say that everything is going to be considered a multiple until it fails. Once it fails, then we should go ahead and flip it. And you can see there here that I made the error, but the thing about programming is being good at debugging. All right, so obviously I had declare logic, but my code didn't reflect that. So you want to go through everything step by step. It might have been good if I had modularized this and actually written functions for this. That way it's a little bit more cleaner, so I can go through everything and kind of check that way, or I can write test that way as well. Okay. Eventually, since there are no ways to actually implement like JUnit testing here, I can't really do that. And since this is a tutorial, sometimes I should follow my own good coding ethics. All right. So let's go ahead and actually resubmit this and see if we fix the error. And you guys can see that actually passes. And let's go ahead and submit. And that actually works. Well, this will be it for this tutorial. If you guys like a tutorial, hit the thumb button. If you haven't subscribed yet, subscribe. If you have any better ways to solve this problem, leave the solutions in the comment section, or you can email me. Go to the About channel and you see my email there. You can personally email me with your code, and I can look at it and give you some feedback. I'll see you guys in the next problem. All right. I hope it's as good as this one. Bye bye.